Sorry, I didn't mean to end that video so soon. Here's our next problem. h of x equals 2 to the power of x minus 3, and it gives us -2, -1, 0, 1, and 2 for our x values. Create an input-output table for f of x. Go ahead and pause the video, do that. Okay, so I'm going to do the first two because they're the hardest because your answers end up being fractions. So if x is -2, so h of -2 is equal to 2 to the power of -2 minus 3. So when you have an exponent that's negative, all you're going to do is you're going to go 2 to the power of 2, which is 2 times 2 is 4, but we're going to make it a fraction, and we're going to make that 4 the denominator. So it's 1/4, and then we're going to drop down the 3, minus 3. Okay? Now we have 1/4 minus, and we need to make this 3 a fraction, so it's 3 over 1. Now you cannot subtract fractions that have different denominators. So 4 is the least common denominator, so we need to get a 4 on the bottom over here. We're going to do that by multiplying the top and the bottom both by 4. So now we have 1/4, it's just getting dropped down, minus 3 times 4 is 12, 1 times 4 is 4. So 1/4 minus 12/4 is equal to a -11/4. And we put that in our table over here. We'll do it again with -1. h of -1 is equal to 2 to the -1 power minus 3. Negative exponent, so we're 2 to the first power is just 2, but we're going to make that the denominator. So 1/2, drop down the minus 3. Now we need to make 3 a fraction, so 1/2 minus 3 over 1. They have different denominators. We need to get them to be the same. So we're going to multiply this one, top and bottom, by 2. That keeps this the same value. It doesn't change the value of this fraction, but it gives us a common denominator. So we bring this 1/2 down, we bring the subtract down. 3 times 2 is 6, 1 times 2 is 2. So now we have 1/2 minus 6/2 gives us a -5/2. So you're going to follow the same pattern for all these other values of x. Take 0, plug it in for every x, and you should get -2. Take 1, plug it in for every x, you should get -1. Plug in 2 for every x, and you should get 1. I erased that problem before I did the inference on it, but as the input increases, the output also increases. So as the x values got higher, so did the y values. All right? All right, so here's the next one. If we take negative 3 as our x value, we have k of negative 3 equals 3 to the negative third power minus 1. My answer does not match what's in the book, and I don't know if it's because I'm stupid or because the book's wrong, because sometimes the book is wrong. So we have 3 to the negative third power is 3 times 3 times 3, which is 27, but 27 becomes the denominator. So 1 over 27 equals 1. We need to make this a fraction, so 1 over 27 minus 1 over 1. We need to make these have a common denominator, so we'll multiply top and bottom by 27. 1 over 27 minus 27 over 27 would give us negative 26/27. The book says that I should have positive 1 over 81. No idea where they got that, but you know, whatever, you do you, boo. On this one, the book and I also don't agree, so maybe I wrote down the original problem wrong, I don't know. But if you take this formula and the value of 2 for x, you have k of 2 equals 3 to the second power minus 1. 3 times 3 is 9. 9 minus 1 is 8. The book says the answer's 3. So again, I don't know. Oh, you know what it is? I just figured it out. It's because it shouldn't be 3 to the power of x minus 1. It should be x minus 1. Like that. Well, I'm not going to bother to redo it. Okay, it was bothering me too much, so I went back and did it. Yeah, you know what? Their answers are right if you write the problem down right. I'm a genius. This one is a word problem that's talking about a principal that wants to order shirts for their school. And this is the formula. C of n is equal to 7.50 n plus 52. And they want to know how much it would cost to get 300, 350, 400, 450, and 500 shirts. So you're going to go ahead and make a table and then fill out that table and see what you get. Also make an inference at the end about the results on your table. Pause it, do it. Okay, I feel like this lesson kind of beats a dead horse. Like, it does so many problems and it's all the exact same stuff. So this is the table, this is the information, and we'll just do the last one. So for 500 shirts, it's C of 500 is equal to 7.50 times 500 plus 52. All we're doing is taking our last x value, 500, plugging it in for each x, and then solving. So we multiply 7.50 times 500, take that answer, add 52, and you end up with $3,802. And what this shows is that we can infer for the more short shirts they order, the higher the cost is going to be. Shocker. This problem is a word problem talking about revenue and profits based on units sold. So the formula is R of P is equal to negative 4P squared plus 120P. And they want you to use 5, 10, 15, 20, and 25 for your values of P. Go ahead and pause it and solve it. We'll come back and I'll show you the answers. Nothing new or fancy here. So here's the table for the first 4 answers. We'll work the last one together. The number of phone cases sold, or P, is 5, 10, 15, 20. The revenue, R of P, is 500, 800, 900. Sorry, that's 800, not 80. 800. Again, I'm a smarty. Now let's do the last one together. Okay, here's the last one. If we use the value, the x value of 25, then we have R of 25 is equal to negative 4 times 25 squared plus 120 times 25. So we need to do PEMDAS. This is the only thing that might trick you up here. First is exponents. We do parentheses, but the parentheses don't have anything in them. They're just single numbers. Then exponents. 25 squared is 625. So we have negative 4 times 625, and then 120 times 25 is 3,000. Negative 4 times 625 is negative 2,500. So negative 2,500 plus 3,000 gives you 500. What you can infer from this problem is that the revenue increases until 15 units are sold, and then it decreases. This problem just wants you to complete the table for C of n is equal to n squared minus 40n plus 500. It gives you 5, 10, 20, and 40 for the values of n. These two are already answered, so you don't need to worry about them. Just ignore them completely, solve for 20 and 40, then come back. All right, so if we take the value of 20, c of 20 is equal to 20 squared minus 40 times 20 plus 500. 20 squared is 400. Negative 40 times 20 is negative 800. Drop the 500 down, do the math, you get 100. Plug it into the table. C of 40 is equal to 40 squared minus 40 times 40 plus 500. 40 squared is 1600. So we have 1600 minus 1600, which cancels out, plus 500, so the answer is 500. This one's another word problem talking about the amount of medication in milligrams that remains in the body T hours after it's taken. So it's A of T is equal to 100 times 0.5 to the power of T. And it wants you to create a table using the values of 0, 1, 2, and 3 for the value of T. Go ahead and pause it, solve it, come back. Again, nothing special or fancy going on here, so we'll do the last one together. So we take the values of x, plug them into this formula, and the values for t. I'm tired. And then solve it out. So 0 is 100, 1 is 50, 2 is 25. If we take 3, we have a of 3 is equal to 100 times 0.05 to the third power. We have to do PEMDAS, so we're going to do the exponents first. 0.05 to the third power is 0.125. So 100 times 0.125 ends up being 12.5. All right, this is the practice for Unit 7, Lesson 5. It says, use the table to answer the question. This table is used to determine the value of the car after 5 years, which is currently unknown and represented by the question mark. So we have years, x, value of car, f of x. At 1 year, it's worth $29,750. 2 years, it's $25,287.50. 3 years, $21,494.38. 4 years, $18,270.22. 5 years, question mark. A car decreases in value after a given number of years. The following function represents the value of the car in dollars with respect to its age, x, in years. So here's our formula right here. F of x is equal to 35,000 times 0.85 to the power of x. Use the input-output table to determine the value of the car after 5 years. Round your answer to the nearest cent. Okay, so we can ignore all of this. All of this is irrelevant because it already gave us the answer. We just need to take this formula, plug in our value for x, which is 5, and find the answer. Pause it, try it. Okay, so substituting 5 for our x value, we have f of 5 is equal to 35,000 times 0.85 to the fifth power. You have to do PEMDAS, parentheses, it's just one number, exponents is next. So 0.85 to the fifth power is this big long number right here. Originally, I rounded it to the cents because it says that it wants our answer rounded to the nearest cent. But then when I multiplied it out, I ended up with 0, 0 in our cents, and I'm like, that's probably wrong. So this is the total number for 0.85 to the fifth power. It's 0.4437053125. If I take that and multiply it by 35,000, the final answer, rounded to the nearest cent, is 15,529.69. For your quick check on this section, use the table to answer the question. Make the table like the one to determine the missing values of f of x for different values of x. So for x, we have negative 1, 0, 1, and 2, and it wants you to find the values for f of x. It says finish creating the input-output table for the function f of x equals x plus 1, this is all in parentheses, squared, plus 4. Which of the given x values produces the largest output of the function? So here it's telling you to complete this table, but then the actual answer it wants is down here, and it wants you to plug in these values into this problem and figure out which one of these is correct. I'm not going to do it because this is your quick check and you should be able to do this on your own.